Right, so this next one is 2007. Okay, again, they're asking you to calculate the size of the file. They're then asking you to work out how many pictures you can fit in a 512 megabyte card. Okay, now these ones, the newer questions, they seem to be asking you to work out the number of pixels along the way and down the way. This one's actually, they're telling you. What is different is they're not actually telling you the colour depth, they're actually asking you to work out the colour depth by telling you how many different colours it supports, okay? But it's very similar to the other ones that we did. So, first thing we want to do is we're going to look at calculating the size. Now, it's always handy just to draw out the image, so that's 3000 pixels by 2000. Okay, so that's already been done for you. Now, we're looking to work out the colour depth from that. Now, there'll be some that you'll be familiar with. So, for instance, 2 to the power of 8, that's 256. If I did 2 to the power of 16, that's 65536. And 2 to the power of 24, if it's none of these, then it's a good chance it'll be 2 to the power of 24. And that's the one we're after, okay? So just reverse engineering it, that number of colours, you can get that if you've got a colour depth of 24, okay? And that's known as true colour. So we've now got all the information we need, so all we're needing to do to calculate the number of bits, you just work out the number of pixels and times it by the colour depth. And that's exactly what we do. Okay, so we just say number of bits equals 3000 times 2000. Okay, so that calculates, I can just say that's essentially number of pixels. And then times that by 24, and that's your colour depth. So just put this in a calculator. So we've got 2000 times 3000, then times 24. And the size of the picture is 144 million bits. Now, obviously, that's far too big, and so we need to change the units. So we divide that by 8. That gives us 18 million bytes. Move this up so you can actually see it. We then divide that by 1024, so we divide that by 1024, and that will give us, this is going to be in kilobytes, 17578.125, and that's in kilobytes, and we can still change the units again, so we'll divide that by 1024 to get it into megabytes, so 1024, and this is in megabytes, so this is 17.17. Okay, we'll just round up. So each picture is 17.17 megabytes. Now, what we're now wanting to do is we're now wanting to, and if you actually look at the marking scheme, they do actually round it up even further. They've just 17.2. Okay. Now we're wanting to work out, so that's for your 3 marks. Okay, so get a mark for this, get a mark for that, and get a mark for that. Now we're now wanting just to work out, well, what's the maximum number of images you can store in John's memory card? You can tell it's quite an old paper because they're talking about cards just of that size, so that's 512. Okay, so we just say number of pictures, and that equals, well, there's 512 megabytes available, and each one is 17.2, so 512 divided by 17.2. That will give you 29.77, but we don't want a 0.77 or a 0.76 of a picture, so we just rounded it down, so 29 pictures. So just to recap, more often than not they won't give you it in pixels, okay, they'll give you it in inches, and you get given the resolution, you work it out that way. But calculate the number of pixels, times it by the colour depth. If they don't give you the colour depth, just try and memorise these, or at least just know the values that you can work out in your calculations. So you times the number of pixels by the worked out colour depth, and then you just reduce it down so you get a nice size number. And then quite often, more often than not, they're now trying to ask you how many of these files will fit into some backing storage.